Picture a swarm of 5,000 locusts. But instead of biological wings, they have carbon fiber rotors. Instead of a simple hunger for crops, they possess a cold, calculated artificial intelligence. And instead of a field of wheat, they are hunting for a very specific strategic target. For the last 3 years, the Middle East has become a terrifying testing ground for a new kind of warfare. The era of cheap, mass-produced Iranian UAVs. These drones, led by the infamous Shade series, have bypassed multi-million-dollar defense systems, not through stealth or speed, but through sheer, overwhelming volume. They have turned the math of war against the West. But today, in March 2026, the rules of that game have been permanently rewritten. Deep within the American heartland, protected by layers of high-tech security and miles of restricted airspace, the United States is firing back. Not with a bigger, more expensive missile, but with a million smaller, smarter ones. Welcome to the world's first fully autonomous drone swarm gigafactory. This is not a traditional defense plant. It is a $2 billion high-tech fortress designed for one thing: the total neutralization of the Iranian UAV threat. Today, we're taking you behind the curtain of the most secretive and advanced industrial facility on the planet. We will show you how America is building an army that never sleeps, never misses, and most importantly, ever retreats. To understand why this factory represents such a massive shift, we have to look at the brutal economic reality of modern conflict.
Project Replicator ensures we meet the Q3 deployment targets. The automated assembly of the Coyote drone is fully optimized.
All systems operating within optimal parameters. Rhythm synchronization achieved.
An Iranian Shahed 136 drone costs the Iranian Revolutionary Guard about $20,000 to produce. To shoot it out of the sky, the US and its allies have been relying on Patriot missiles that cost $4 million each. You don't need to be a 4-star general to see the flaw in that equation. The US was essentially being bankrupted by cheap plastic drones. The Pentagon's answer arrived in the form of Project Replicator. This $2 billion facility was built in record time with a single, uncompromising goal: to flip the economic script of war. Here, the United States is mass-producing the Coyote Block 3 and the Boltex fully autonomous interceptors, designed to operate not as individuals, but as a single, terrifying hive mind. What makes this factory different is its scale. We aren't talking about a boutique assembly line building 10 drones a week. We are talking about a relentless 24/7 operation capable of producing 10,000 drones every single day. As we step onto the factory floor, the first thing you notice is the atmosphere. The air here is filtered to 99.9% purity. There is no smell of grease, no sound of heavy stamping presses, and no sparks flying. Instead, there is a low frequency of high-performance servos and the rhythmic soft click of precision components being merged at speeds that defy the human eye. This is the birthplace of the swarm. Everything begins with the brain. Every single drone produced in this gigafactory carries a neural mesh processor. This is not the kind of GPS or flight controller you would find in a commercial hobbyist drone. This is a military-grade AI core, capable of over 100 trillion operations per second. This processor allows each drone to navigate without GPS, using nothing but visual landmarks and starlight. Watch this robotic arm over here. It is picking up a microchip the size of a fingernail and placing it onto a gold-plated circuit board with a tolerance of less than 5 microns. In traditional aircraft manufacturing, thousands of rivets and bolts are used to hold a frame together. But in this factory, drones are grown through a process called high-speed carbon infusion. Multiple white robotic arms move in a synchronized dance, spraying a liquid carbon fiber composite into a precision 3D mold. Within seconds, a drone chassis emerges. It is stronger than titanium, but lighter than a feather. This additive manufacturing process is the key to America's new agility.
Monitor the stress test results on the holographic display.
Acknowledged. All parameters are stable.
If Iranian engineers in Tehran change the frequency of their drones or update their flight patterns, the software in this factory is updated instantly. The next batch of 10,000 drones coming off the line will already be optimized to defeat the new threat. The factory itself is a living, learning organism. As we move deeper into the facility, notice the workers. You won't see anyone covered in oil or soot. These are data architects and precision technicians. They wear bright yellow, pressurized protective suits, hazmat-style gear that ensures not a single skin cell, speck of dust, or stray static charge enters the sensitive assembly bays. Each of these yellow suits is responsible for overseeing a section of 500 independent robots. It is a 1:500 human-to-robot ratio, a feat of industrial automation that has never been achieved in human history. Now we enter the software integration bay. This is the secret source of the $2 billion gamble. Here, every drone is born into the Hive. Unlike older generations of drones, these units are not programmed with a set flight path. Instead, they are given an objective and a set of rules. When you launch a swarm of 1,000 Coyotes, they don't need a human pilot in a trailer in Nevada to tell them where to go. They talk to each other through an unhackable, encrypted mesh network that exists only between them. This mesh network is what keeps Iranian commanders awake at night. If you manage to shoot down drone number 452, drones 453 and 454 instantly detect the loss. They don't panic. They don't wait for orders. They simply calculate the mathematical gap in their formation and adjust their flight path to cover the sector. You cannot jam a swarm of this magnitude. If you try to jam one drone, the other 999 act as relay stations, bouncing the signal around the interference. This factory is producing a weapon that actually gets smarter and more resilient the more units you add to the pile. It isn't just a drone. It's a distributed supercomputer with wings. But a weapon is only as good as its reliability. Before a single drone leaves this facility, it must prove it can survive the most extreme conditions on Earth. While Iranian drones are often built to be disposable and prone to mechanical failure, American swarm drones are built to be attritable but resilient. In the high voltage lab, we witnessed the EMP shielding test. We see a drone hit by a massive simulated lightning striker blast of electromagnetic energy that would fry any consumer electronic in a second. The drone shakes for a moment. Its AI core reboots in milliseconds, and it stabilizes its flight. This is the answer to the Iranian electronic warfare units.
System overload detected. AI core rebooted. 0.003 seconds. Full status restored.
Next, we move to the ballistic testing chamber. This is where the kill chain is verified. The American swarm drone doesn't carry a traditional explosive warhead that might fail to detonate. Instead, it is a kinetic interceptor. It uses its own body as the bullet. We watch a slow-motion feed of an American drone, identifying a mock-up of a Shate 136 flying at high speed. The American interceptor doesn't fire a shot. It simply accelerates to Mach 2 and rams into the target's engine block. Total, absolute destruction. By making the drone itself the ammunition, the Pentagon has effectively reduced the cost of an aerial kill from $4 million per shot to just $15,000. For the first time in the history of aerial warfare, the defense is officially cheaper than the attack. This is how you win a war of attrition. The final stage of the process is a masterpiece of modern logistics. How do you deploy a swarm of 5,000 drones at a moment's notice? You don't use a traditional runway or a vulnerable airbase. These drones are packed into smart crates, pressurized containers that double as launch platforms. These crates can be dropped from the back of a C-130 Hercules, hidden in a standard shipping container on a civilian freighter, or even fired from the back of a tactical truck in the middle of the desert. Once the crate hits a certain altitude or receives a remote signal, it opens like a flower, and the swarm activates in midair. This entire factory is connected to a dedicated high-speed rail line and an underground military airfield. The efficiency is staggering. From the moment a robotic arm installs a solid-state battery into a chassis, to the moment that drone is patrolling the skies over the Persian Gulf, the total elapsed time is less than 72 hours. This is the industrial might of 2026. This is a supply chain built for a world where wars are no longer won over years, but in the first 48 hours
The
of
encryption
engagement.
status is confirmed.
The $2
Mesh
billion
network is fully
Drone
active.
Swarm Gigafactory
Acknowledged.
is more than just a
Finalizing
collection of
pre-flight check.
robots and clean rooms.
Certifique-se de que a carga esteja bem segura.
Confirmado, sargento. Indo para o próximo palete. Keep it coming slow. Watch the clearance on the left.
Almost there. Push it forward.
Ativação no ar. Close up. Swarm dominance established.
A escala da distribuição. Centenas de caminhões militares e trens sendo carregados simultaneamente. O volume de equipamentos é impressionante.
Clear the ramp. Bay is secured. Lock it down.
O fim das plataformas requintadas.
As you can see in the simulation, the defensive dome, comprised of 10,000 Coyote drones.
It represents a fundamental, permanent shift in the history of human conflict. For nearly a century, the United States relied on the concept of exquisite platforms, fewer, extremely expensive, and incredibly complex machines. The B-2 Spirit, the Ford-class aircraft carrier, the F-35 Lightning. These are masterpieces of engineering, but they are vulnerable to the power of the many. Against a swarm, you need a swarm. By merging cutting-edge AI, autonomous robotics, and the kind of mass production that once made America the arsenal of democracy, the US has built a shield that the Iranian UAV program simply cannot penetrate. The era of cheap, unopposed drone attacks against American interests is over. The technology inside these walls has neutralized the threat before the enemy even knows the drones have been launched. As we exit the facility, we look back at the floor. The white robotic arms aren't stopping. They don't take breaks for coffee or sleep. They don't go home to their families. They are building the future of global defense, one carbon fiber wingspan at a time. The message being sent from the heart of America to the rest of the world is crystal clear. America has returned to the factory floor, and the swarm is ready for whatever comes next. What do you think? Has the age of the human fighter pilot officially come to an end? Is the future of war just a battle of algorithms and assembly lines? Let us know your thoughts in the comments below. This is a rapidly evolving story, and we will be here to cover every major breakthrough in the world's most advanced megafactories. Don't forget to hit the subscribe button and turn on notifications so you never miss a deep dive into the technology shaping our world.
The mission is a
Thanks for
success.
watching, and we'll see you in the next one.
After all this time.
O escudo de carbono.